What's up, Marco? Good to have you here, bud. I was a little late sending that email out, so I'm gonna wait a couple minutes and then I'll get started. And yeah, you tend to be pretty much the first one we have most days. Hey, Michaela. Awesome to have you with us. I think Michaela beats you here most of the time, Marco. She just doesn't say hi, hi, hi right away. Alright, I hope you guys are doing well. Thanks for waiting a minute or two while we wait for a couple classmates to possibly join. But then we'll get started and they can watch the recording if they're a little bit late. How you doing, Mr. Chu? Alright, 2:04, one more minute and I'll get started. Alright, bring my camera in. Alright, it's good to see you all. I'm going to get started on the lesson now. Hopefully you kind of got a bit of a head start. I think for those of you who join us live each day, it's a great idea to take a look at this work and try to do a few of the problems on your own before I get started. If you're just with us now, that's fine too. I would encourage you to do your best to always kind of work ahead of me a little bit, or at least anticipate what some of my answers are going to be. Alright, our whole goal today is going to be focusing on, as the lesson's called, graphing linear equations. We have a few questions here. The first one is, why do we create graphs on the coordinate plane? We've spent a bunch of time starting to make graphs, look at the equations that match them. Quickly, I just wanted to cover this. The purpose of a graph, or why we create graphs, is because graphs show us all of the possible solutions to an equation. When you have equations with two variables, there are lots of possible solutions. And that's almost a better first sentence for me to start with. But basically, when you have equations with two variables, you get lots of possible solutions. And the graph is a way for us to visually show all of those different solutions at the same time. And our big goal today is going to be pretty much, how can we create a graph if we give you an equation with two variables, an x and a y in them? And then also, if they give you a graph, how do we find the equation to match that graph? You're going to see a lot of this lines up with the first three Khan Academy assignments this week. So problem 1 gives us 4 different practice problems to work on, but for problem 1, for each one of them, they're going to give us a linear equation. And then it's our job to do a couple things with that linear equation. Our first job is to identify, if it's in this y equals mx plus b form, this slope-intercept form, what is the y-intercept and the slope? And then once we find that information, our job is going to be to use the y-intercept and the slope to create a graph. Up here on the, now we have some notes, and a few of these notes I just want to touch on quickly. Slope-intercept form is y equals mx plus b. And the b is missing there. We're going to go ahead and add that b in. So slope-intercept form is y equals mx plus b. And the m is going to always stand for slope, which represents our rate of change. How you doing, Donald? Good to have you with us. And the b is always going to represent the y-intercept, or the beginning point. Remember earlier we noted that the graph is going to be lots of different solutions to this equation. The y-intercept is really going to be our solution when x is set equal to 0. And we can find that solution by looking, where does the line cross with the y-axis. So here we see our y-intercept is going to be this -4 that's all by itself. That's in the b spot. So I'm going to go ahead and plug that in. If that's the y-intercept, they're really saying if you make x 0, if we were to cancel out the entire 2/3 x term, y would have to be equal to -4, and that's your first solution. That's really what the y-intercept represents, the easiest solution to find, and if it's in y equals form, it's just the b, the number that's all by itself without the mx term. If the -4 represents the y-intercept for us, then the slope, the m piece, is going to be this 2/3 right here. So I'm going to go ahead and enter a slope of 2/3. That's what's multiplied with x. Now once I understand the y-intercept and the slope, the key to making a graph is to recognize the y-intercept is the first point on my graph, and then the slope, which we use this letter m for, slope describes my movement, my rise over run, as you see my mouse highlighting. Rise describes up and down, so the top of the slope fraction tells you how much to move up or down, and then run describes how much the x should change by how much to move left or right. So here, if our y-intercept is -4, when you open this graph up, your job is going to be to plot a y-intercept for -4. So to do that, you're going to have to click on the graph twice, and recall here that our y-intercept was -4, so that means it's going to go right here. Now our slope, if you recall, was 2/3. So if our slope was 2/3, that means that we're going to be going up by 2, 1, 2, every time we go right by 3. Again, our slope is our rate of change, our rise over run, so I go back to the y-intercept. I use a slope of 2/3, which tells me I will grow or move up by 2 every time we have to move right by 3. I'm going to follow that pattern again to get another data point. I'm going to go up by 2 more units and right by 3 units. And if you're at home, you don't have to go place this line on the graph, but I think it's a good idea to see what this line represents. It's going to follow this pattern, so I'm going to put a dot one corner there, and then you see my mouse hangs over the corner of the line, which allows me to drag that through all 3 of those dots. So I'm going to do a great job there, yeah. And then you can kind of just move both ends of the line around, and that can help you kind of get a line that goes through all 3. But again, you don't have to draw this line in there if you see all 3 dots are forming a straight line. The main reason I'm showing you this line is this represents all of the possible solutions. So this data point right here that I'm hovering over, and I'm going to go put a little purple data point over it, this data point right here in purple would also represent another solution. -3 for x, -6 for y would be another different solution to this equation, and that's one of the purposes of these graphs that we make. Okay, hopefully if you are now watching on recording, I would pause the video and try to create the next 3 graphs on your own. If you're with us live, I'm going to talk through it a little slowly in the hopes that you're kind of anticipating this and filling this out on your document ahead of me. For our next graph, we have y equals 3/4 x plus 2. So marking that up a little bit, our y-intercept is going to be the plus b, the number that's all by itself, or in this case, that plus 2 really represents our y-intercept. The slope is going to be the m, whatever x's coefficient is. So in this case, our slope is going to be what I'm circling in red here, that 3/4. 3/4 here represents what's ultimately going to be the slope for this equation. So I'm going to go ahead and enter those numbers 0 and 2. If you make the x value 0, this equation says my y value starts out with a value of +2. And then it also says for every 4 x's, the y will go up by 3, or our slope is a rise of 3 and a run of 4. So when you go and make this graph, I'm not going to double click on it, I'm just going to start drawing on this screen a bit here. When I make this graph, I'm going to go ahead and plot this first y-intercept at the +2 point. So that will be where your first dot goes. And then the slope of 3/4 tells me that I need to go up by 3 and right by 4. So that's where that next dot would go. And now you'll notice if I try to follow that again and go up 1, 2, 3 and right by 4, I fall off the graph. So instead I'm going to go the reverse, back in time. I'm going to go down by 3, and I'm going to go left by 4. And I'm going to place another dot there. And this here now represents for us the linear equation that you're hoping to get there. That line there would represent every single possible solution to the equation y equals 3 over 4 times x plus 2. Similarly, down here in purple, we see it says y equals 3x plus 5, so that tells me that my y-intercept is going to be 0 and 5. And it also tells us that our slope is going to be this 3 that's multiplied with x. And if it's really a 3 for slope, we're going to plug in 3 over 1 for our slope. 3, remember, anytime you have a whole number, you can turn it into a fraction by just putting it over 1. So if the slope is ever a whole number, it's really just saying y grows by 3 every 1x. So I'm going to put my slope as 3 over 1. Again, that y-intercept was 0 and 5. And if we pull these notes back up here, I'm going to go ahead and plot a y-intercept of positive 5. So that's going to go right here. And then a slope of 3 says up by 3, 1, 2, 3, and right by 1. We're at the end of the graph, so I could also go down by 3, 1, 2, 3, and left by 1. So this would kind of be the graph that you start to create there. And then you would see your line traveling like that for the purple graph. For our final equation, we see y equals negative x minus 3. And if it says y equals negative x minus 3, you need to think back to last year with Mr. Neville, and he would have reminded you whenever it says negative x, a very helpful thing to understand, this is really a negative 1x. It's really negative 1 times x, which tells me that my slope here must actually be negative 1 over 1. If the slope is negative 1, I'm going to just put that over 1 to turn it into a fraction so it makes a bit more sense for my slope. My y-intercept is this negative 3, that number that's all by itself there. So I'll plug that in for the y-intercept. And if we have a y-intercept of negative 3, I'm going to have to scroll down a little bit. Shoot. If we have a y-intercept of negative 3, a lot of this other stuff is messed up now, but we don't really need it anymore. Our y-intercept of negative 3 tells us we're going to go ahead and plot a point right here for negative 3. And then a slope of negative 1 means down by 1 and right by 1. Every time this graph loses 1 unit for y or travels down by 1, it's because we grabbed 1 more x or moved 1 more unit to the right. So there you see this graph would keep traveling down 1 and right 1, or the reverse, you could also go up 1 and left 1, which is kind of like traveling back in time. We're just doing a slope of positive 1 over negative 1. Go ahead and draw a quick line that goes through those. And that's what your graph should look like for the final orange one. Hopefully that was helpful. That's what you're going to see for the first Khan Academy assignment. It's also one of the IXL ones where they'll give you the y equals mx plus b equations and ask you to build out the graphs. Okay, we're going to keep moving now on to the second problem, the bachelor's level problem in light red here. And for the second problem, it's the reverse, or almost the opposite of what we just looked at for the first problem. Here they're going to provide us with linear equations, or the graph for the linear relationship, and our job is to figure out what was the equation that made that graph, or what equation would match that graph. In red here, we see this linear graph, this linear equation is traveling here, and the first thing I'm going to look for is my y-intercept. That's going to be on a graph the point where the line crosses with the y-axis. And I see for this red line right here, the little green dot I'm drawing, this represents, for us, the y-intercept. And we see it's right at a value between 3 and 5. It crosses right through the graph at a positive 4. So that tells me that my y-intercept for this first graph is going to be 0 and 4. And then for slope, the other thing that I'm going to have to figure out to ultimately write an equation for this graph, slope, remember, measures the rate of change, or rise over run. How much is the graph moving up and down? That's the y change. Compared to how much does it have to move or run side to side. That represents x change. So I'm going to look here, and I see these. I could use any two data points on the line. I'm going to use these two right here. And I see I need to climb up and to the right. Specifically, I need to climb up by 4 units, and I also need to climb to the right by 2 units. So this here tells me that my slope needs to be positive 4 over 2. My slope is ultimately going to be positive 4 for the numerator and positive 2 for the run, or the denominator. And 4 over 2 actually simplifies to 2 over 1. And 2 over 1 simplifies even further to just 2. So I'm going to plug my slope in here as just positive 2, which is the same thing as 2 over 1. And I'm also going to plug my y-intercept in as 0 and 4. So again, the y-intercept is 0 and 4. That point where the line crosses with the y-axis, it represents the easiest solution to find, maybe. And then our slope, it was going up by 4, right by 2, but I simplified that 4 over 2. And I just simplified that down to 2, because 4 divided by 2 can become an integer, or 2. So now, if I know that my y-intercept is 0 and 4, if I know that my slope is positive 2, all I need to do is use that y equals mx plus b equation, and the m's going to get replaced by slope. So my m is going to become 2. And the b will be replaced by my y-intercept. So in this case, the b is going to be replaced by that 0 and 4, and all we do is plug in the y value. Again, every y-intercept has an x value of 0, so we really, for the equation, just focus on its y value. At this point, hopefully that makes sense for how to find a y-intercept and a slope on the graph, and then how to use that information to write the equation that would match the graph. If you're with us live, please try to start working out the green, purple, and orange one on your own. And if you're watching on recording, please pause the video and try to do those before you take a look at how I get done. Alright, so coming back to our work and cleaning up some of the old stuff. Now we're looking at this green graph, and the first thing I need to find for that green graph is going to be the y-intercept, and that y-intercept for the green graph happens to be sitting right here. So that y-intercept, the coordinates are 0 and 5. And then to measure slope, again, we're going to need to use 2 data points to measure our slope. I'm going to use this data point and that one down here, and I'm going to measure how much does it travel down and how much does it travel to the right. And here I see for this one it goes from positive 2 all the way down to negative 4, and if I count that out, that's going to be 6 units to go from positive 2 to negative 4. And I'm going to put a negative 6 because we're climbing down by 6 units. The y is losing value. We also then climb to the right, or move to the right, by 2 units. So I'm going to go ahead and put that 2, and I'm going to put it as a positive 2 because we're moving to the right, and as I move to the right for x, x is gaining, that's positive. So that tells me my slope is negative 6 over 2, but I know negative 6 divided by 2 can divide evenly to an integer, or a whole number, and the integer that negative 6 divided by 2 comes out to is negative 3. And I can see now, also on this graph, I can see that negative 3 slope. We could go down by 3, and we could go right by 1. That down by 3 and right by 1 is also on the graph, and you might have seen that using those 2 data points. So if our slope is negative 3, we have a negative 3x. If our y-intercept is positive 5, our whole equation becomes y equals negative 3x plus 5. Scroll down, take a look at the next 2. For the purple one, I see that it crosses the graph right at the negative 3, so that tells me the y-intercept is going to be 0, and this time it's a negative y-intercept. Y starts out on the negative side of this number line, specifically with a value of negative 3. The slope, then again, I'm going to need 2 data points, and I'm going to go ahead and use these 2 data points. What I will really find, you want corners of grid boxes, but the closer the points are together, the less simplifying you have to do. So I'm going to choose these 2 data points that are right near each other. I see that it climbs up by 1, and it climbs right by 2, so that tells me I have a rise of plus 1, and I have a run of plus 2. So our slope here is not going to be 2 over 1. The bigger number doesn't always go on the top. Slope, remember, is rise over run. And here our rise, our up and down movement, was 1. So it's going to be 1 over 2 for a slope. Saying y will grow by 1, but you need 2 x's every time to make y grow by 1. So if that's our slope, 1/2, and it starts with a negative 3y intercept, our equation will be y equals 1/2 times x minus 3. If you want to make that 1/2 look like a fraction, you do not have to be doing this at all. But if you want to know how to make equations that have fractions in them, you're going to have to go up to your menu and hit insert equation, and then you'd be able to type in this fraction that looks like this 1/2 right here, which I'm just going to kind of copy and steal and place in there. But again, if you're trying to go ahead and make that, you would ultimately have to go insert equation, but it's totally fine to write your answer as 1/2 x, just like I did there. Last one, this is getting pretty lengthy, so I'm just going to put our answers in. The y-intercept is at -4. It crosses the graph down here at -4. And our slope, we see this graph is climbing down by 1, and it goes right by 3. Again, following my mouse here, down by 1, right by 3, means the slope will be -1 over 3. And that means my equation is going to be -1/3 x minus 4. And again, if you want to turn that -1/3 into a fraction, we'll go ahead and show you how to do that here quickly. Or it's still a fraction, but the better looking fraction. You hit insert equation. Here I've already got an equation going, so I'm actually just going to hit view, show equation toolbar. And whenever I insert an equation, now this toolbar should pop up. If you don't see this toolbar that I'm looking at right now, you just hit view, and then you check off show equation toolbar. And whenever I'm in equations, this toolbar lets me put fancy things into the equation. One of those fancy things, it allows me to put a fraction. This menu right here with the square root symbol, if I click the a over b symbol, that plugs a fraction in. I type my -1 in, and then you use your left and your right arrow keys. If I use my left and right arrow keys, it lets me move through the fraction. So I type the -1, I hit right on my arrow, and now it puts me at the bottom of the fraction. I can type in 3. But again, it's totally fine to use that just slash. It doesn't look quite as regular as a fraction there. The way I've written 1/2 x over here is completely fine as you're at home. Alright, that brings us to the end of this. This is going to help you out with the first 2 Khan Academy assignments. And now for the master's level and the PhD problems, we're going to take a look at linear tables. A linear table is very much related to linear graphs and linear equations, but instead of showing you an equation, or instead of giving you a visual graph that has all of the solutions shown as a line, the table just picks out a few of the solutions from a graph, or maybe they found them from the equation, and then they list those solutions in a table. This could also be like when you're a scientist gathering data for your relationship, and you're going to organize it in a table before you try to make a graph and before you try to find an equation to match that graph. So they tell us this table shows a linear relationship, and they ask us to figure out about a couple things for it. The first thing they're going to ask us to figure out here is they say, what is the y-intercept for this linear relationship? And to help us out, I'm going to bring those notes back up, because our concepts from graphs and tables are still from graphs and equations are very helpful with tables. They ask for the y-intercept, and as you recall on the graph, we were looking for where did the line cross with the y-axis. In the equation, the y-intercept represented the b. It was always the number all by itself in this y equals mx plus b form. And you'll also recall we kept saying the y-intercept is always the value for y. What value does y take when x is equal to 0? So for this situation, I'm going to go ahead and in green, I see right here, oh, give me a second. Why is it giving me that? I don't want that. 1 second as I get the marker tool. There we go. That's the brush. Alright. This I see is 0 for x and 2 for y. And this data point here represents the y-intercept. Again, y-intercept will always be the value for y when x is set equal to 0. So if you're given a linear table, you're looking to see, does the table list an x value of 0 anywhere? And here it's listed right there, so that tells me my y-intercept is 0 and 2. Don't be confused by a potentially x-intercept. You'll get into that more in 9th grade, but we've covered that as well. The x-intercept is the value for x when y is 0, and occasionally, if they're being mean like I was today, they try to list the x-intercept in the table too to throw you off. Now the slope is going to measure the rate of change. And recall, when we were on a graph, we measured rise over run. We found 2 data points on the graph. We measured how much it went up, and we measured how much it went sideways. When we start working with tables, it becomes helpful to start thinking about rise as describing to us, ultimately, how much is the y changing by. And it becomes helpful to start thinking of the run as describing to us as how much the x changes by. So rise measures y change, right, up and down. Run is on the x-axis. It measures how much the x changes. So I'm going to find 2 data points here. I'm just going to go ahead and use the first 2 data points, and I'm going to measure how much the y changes. Y goes from 0 to 1. So that tells me that y must have gained value, specifically y gained 1 unit of value. And the x went from -4 to -2. And so when the x traveled from -4 to -2, it was also gaining value. Specifically, in this case, our x gained 2 units of value, or went up by 2, to go from -4 to -2. So that gives me a slope of 1 over 2. I'm going to plug that in for part B and then put the notes back up. Again, I found a slope of 1/2 by seeing y was gaining 1 as x gained 2. You can see that pattern actually continues. I'm going to go ahead and use another color. Now we see in purple, again, we go up by 1. We're not going to write it out actually, but the y goes up by 1 as the x goes up by 2. And then at the end, the x goes up by only 1, but that's because the y only went up by half a unit, and that's half over 1, or again, we have a slope of 1 over 2, just a smaller jump. So if this is our y-intercept, 0 and 2, and if this is our slope, 1/2, then we know for our equation, this y equals mx plus b equation, we're going to want to put in y equals 1/2 x, 1/2 x plus 2. Again, once you have your y-intercept, the starting point, and the slope, how the line moves, you know everything about the line, and you can quickly write an equation using that y equals mx plus b formula. Alright, so that should hopefully help you get started now as you move into the 3rd assignment on Khan Academy, which has you comparing 2 different linear functions. Number 4, our PhD problem today, is an example of that. So when you get to the 3rd Khan Academy assignment this week, they're going to have you compare 2 different linear functions that are taking different forms. Some will be graphs, some will be equations, and some ultimately will be tables. Here for problem 4, they say consider the following 2 linear functions. And our 2 linear functions are provided. Number 1, function 1 is an equation. And then function 2, our other one. So function 1 is going to be the equation in purple, and function 2, we have a table for that one. So function 2, which I'm going to call the green function, is shown as a table. Function 1, which I'm going to call the purple one, is shown as an equation. The first one, part A, says which function has the greater y-intercept. So I need to figure out, if I want to make a comparison between 2 linear functions, I need to know the y-intercept for both of them. So I'm going to first take a look at the equation, and for the equation, it is in y equals mx plus b form. The y is all by itself, so I know whatever the b is, or in this case, the -4, that represents our y-intercept there. If I make the x value 0, that would cancel out the -3/7x, and y would be 0. So this does indeed tell me, for this first function, if x is 0, y needs to be -4. That's really the y-intercept there. And when I take a look over at the table, I see the table has listed a y-intercept for me. The y-intercept, recall, is the value for y when x is 0. And over on that table, I see 0 and 2 is the very first row in that table. So this tells me the y-intercept for function number 2 is positive 2. The y-intercept for function 1 is negative 4. And so my answer here is going to be function 2 has the greater y-intercept. And the reasoning, positive 2 is greater than negative 4. So if you're looking to explain or support your answer, here it can literally be as simple as saying 2 is greater than negative 4. And what I'm saying is, hey, the y-intercept for function 2, which was positive 2, is bigger than the negative 4 there. So keeping in mind a positive number always has a greater value than a negative number. So I'm going to cancel out now some of the work we did for y-intercept, because the second part now is going to ask us which function has the more negative slope. Again, they're asking us which function has the more negative slope here. So if I want to know which one has the more negative slope, first I need to know the slope for each one. For function 1, it is shown as an equation, y equals mx plus b form. So whatever the m is, in this case, the negative 3/7, that represents the m, or the slope. So the slope for this one is negative 3/7. Then to find the slope for the green table, recall if we're going to measure slope, slope is rate of change. And on a graph we did rise over run. On a table, that really means we need to measure how much is the y changing compared to or divided by how much does the x change by. So I'm going to take a look at this table, and I'm going to go from that first data point to the second data point. And the y value travels from positive 2 to 0.8. So in that case, the y value just lost value, and specifically it lost 1.2 units of value. If you go from 20 to 8, that's going down by 12. That helps me think 2 to 0.8 is pretty similar, just lower by a power of 10, so it's down by 1.2. And during that time, the x value is gaining. The x value has gone up from 0 to positive 2. So the x value has gained 2 units of value during the time that the y value lost negative 1.2. So that tells me that my slope for the second one is going to be negative 1.2 over positive 2. So I'm going to give me a second to set those both up here. And if that's our slope for the second one, negative 1.2 over positive 2, we're going to have to do some division here to figure out what does that work out to. 12 over 20, or negative 1.2 over 2.0. I'm going to go ahead and use my calculator here. 12 divided by 20, or in this case 1.2 divided by 2.0, gives us 0.6. 0.6. It's the same thing as 6 over 10 if you simplify that fraction. So this gives us a slope here of 0.6. And recall, this is going to be a negative 0.6 because we had a negative 1.2 divided by a positive 2.0. And if I do negative 3 over 7, I know that 3 over 6 would be a half. So I know negative 3 over 7 is ultimately going to be less than 0.6. So if it's going to be less than that, but they're negative numbers, this gets a little bit tricky. So I'm going to take this negative 3 over 7, and I'm going to switch that to a decimal for you. And if 3 over 7 is switched to a decimal, 0.428, we're going to round it off to 0.43. So the slope for the red one is going to be a negative 0.43, or about negative 0.43. So this means about, I rounded it off. So if this is our slope here, this can get a bit tricky. 0.6 is greater than 0.43. So I would say negative 0.6 is more negative than negative 0.43. So this one has a more negative slope. Ultimately, function 2 is our correct answer here. And the reasoning being because negative 0.6 is more negative than negative 0.43. A better way to do that would probably have been to have left this as a fraction. Negative 1.2 over 2.0, you could alter that. You could change that to ultimately say negative 12 over 20. And then you could simplify that to negative 6 over 10, because they're both even numbers. And again, you could divide them both by 2 to negative 3 over 5. And if I had done that originally, I wouldn't have to switch that to a decimal. And I would know that negative 3 over 5 is a more negative fraction. It's further away from 0 than negative 3 over 7. So you could have left these as fractions as well. As you see, part of this being the PhD problem, Khan Academy does get a little tough on that third assignment this week. All right, hopefully that was helpful. If you have challenges on any of the Khan Academy assignments this week, please send me an email and I'm happy to help you out. Alternatively, if you go open up our weekly schedule always has video links for each of the Khan Academy assignments. I owe you videos for the last 2 Khan Academy assignments. I'm going to be putting those up this afternoon. But again, if you are ever working on your own on Khan and IXL and you are stuck, each assignment is linked out if it's got a blue link to a video that kind of helps you out. But you can also email me to get some help. Thanks for those of you who hung out and watched with us. Have a good day, and email me if you